Very good morning to all. Again, welcome back to my course, Digital System Learning with Tinkercad Simulation. So, I am Dr. Syed Nagina Parvin, Associate Professor in SR University. In the last class, we have discussed about the universal gates. So, in universal gates, basic introduction. So, we have two types of universal gates. One is NAND gate and NOR gate. Then we have given I have given a introduction about the universal gates, why it is so called as the universal gate. So any type of the gate we can use, we can design using these NAND gate and NOR gates. So that's why it is called it as a universal. And in the last class, discussed about the NOT gate using the NAND gate, as well as the NOT gate using the NOR gate. In today's class, we will learn about remaining basic circuits. So basic circuits, OR gate using the NAND gate, as well as AND gate using the NAND gate, and we have two more, OR gate using the NOR gate, and OR gate and AND gate using the NOR gates. Now let us have a brief overview about the universal gates. So based on flexibility and cost, we are moving towards these universal gates. So truth table for NAND gate and NOR gate. So NAND gate, if any one input is 0, the output is definite 1. In terms of NOR gate, if any at least one input is 1, then definite output is 0, logic 0. Remaining all conditions, the output is high. Now we have NAND gate, NOT gate using the NAND gate. So NOT gate using the NAND gate. So how we have taken a designed a NOT gate using NAND gate by short circuiting two inputs and giving to single input. So we got the NAND gate. Now this is a NAND gate, will act as a NOT gate. So NOT A is equals to A NAND A. Right. Similarly, we have designed using the NOT gate using the NOR gate. So same, the short circuiting two inputs of the NOR gate and giving to single input. Then NOT A output expression is A NOR A. Now the next, similarly, this is our Tinkercad circuit we have designed in the last class. That is, whenever two inputs are on, the definite output is 0. If it is off, the first circuit is NAND gate, that is 7400. Second gate is 7402, that is a NAND gate, NOR gate, right? So when the output input is off, the output is in on condition, right? So same, we used to design using the OR gate by using the Tinkercad simulation. So let us take one new slide. Now OR using a NAND. Now OR using the NAND gate, right? So first, logic expression for NAND gate. So there we have to consider the OR circuit, right? So first let us consider OR using NAND gate. The same circuit we will design through Tinkercad simulation. So we have first OR gate. How many inputs for OR gate? OR, this is a OR gate. Two inputs we have, A and B is a two input. The OR gate output expression is A plus B. Now let us consider NAND gate. The NAND gate also contains how many inputs? Two inputs we have. So these two inputs, NAND gate, AB. Output expression for this NAND gate is Y is equals to AB whole bar, right? Now we have to use NAND gate to get an OR gate, right? Now same NAND gate output expression, that is truth table for NAND gate I am considering 0 0 0 1 1 0 1. The NAND gate is 1 1 1 and 0, right? So if you are considering the OR gate output expression is running the OR gate output expression is A plus B. So it is 1 1 1. So this is output expression. See, we have, this is 1110 and this is 0111. Alright. Let us consider Now this is OR gate expression. So let us consider this. If I use to complement this output expression, that is NAND gate OR gate output expression, then if you apply the using the De Morgan's theorem, so whenever I am using a complement, then A becomes A bar and dot becomes plus, plus becomes dot, right? So first implement this output expression inside, right? So if I use the output expression inside, I will get A bar, then dot becomes plus, B becomes B bar, hold on, right? If I again apply the complement of this expression, then I will get, so A complement double complement plus becomes dot, B becomes B complement, right? So there I will get A bar whole bar is A, B bar whole bar is B, right? So similarly, if I consider, so let us take one more slide, one more slide. So what is output expression for OR gate? Output expression for OR gate is A plus B, right? So if I apply complement on both sides, then I will get Y bar is equals to A plus B whole bar. Then apply this, so you will get A bar. So plus becomes dot, B becomes B bar, right? So this is Y bar. If I apply double complement, we know one property that A bar complement double complement is A, right? So similarly, I am applying one more complement here. Again apply complement. Why? Because if I apply the complement A plus B to double complement of this expression, then I will get A plus B, same as my OR gate output expression, right? So same property I am applying here. A bar bar whole bar, right? So if I again apply the complement, then I will get A double bar whole bar, that is A dot becomes plus B complement double complement is B bar, right? Now this is the expression for the NAND gate, right? But in the NAND gate we have y is equals to AB whole bar. But here in this case I have complement of A bar as well as complement of the B bar, right? It means if I draw the circuit diagram, so input A, so there I will get a A bar. Again input B, if I apply the NOT gate, then I will get the B bar, right? Now what is these two? These two is a product, that is AND gate, that is here I will get A bar B bar, right? And NOT gate again I have, so let us apply one more NOT gate, then I have A bar B bar double bar, so that is equals to A plus B. That is my OR gate output expression, OR gate output expression, right? So what I need to do, I have to consider first NOT gate, then NOT gate for two inputs connected to AND gate. So here if you look at over this, if you look at over this, so here I have AND gate plus NOT gate. What is AND plus NOT? That is definitely NAND gate, right? So let us consider one more new slide, right? So first, why? So I know how to convert not using the NAND gate, right? So by connecting two inputs of the NAND gate to a single input, then it will act as a NOT gate, right? In the same way, so here my circuit diagram is A naught, B naught, two inputs are with a NOT gate, and in the last slide I have explained you about AND plus NOT. So in last this slide I have already told you AND plus NOT is NAND, right? In the same way, so here I got a NAND gate, right? So here it is the circuit. Here I have a basic gate also. This NOT gate is a basic gate, right? So one NOT gate I have, that is a basic gate, and universal gate I have. But what I need to make, I need to make the entire circuit into the universal gate, right? So entire design should be based on either the NAND gate or NOT gate, right? So here I have a NOT gate. So same NOT gate. So I am considering one NAND gate to connect to provide a bar, and one more NAND gate. I'm short circuit to single input. I'm giving to single input, that is B. So whenever I have short circuited the two inputs of the NAND gate, then it will be act as a no, not gate, right? So those two I'm connecting again back to one more NAND gate. So this is a NAND gate, right? So totally how many NAND gates I require here? If you consider this circuit, or if you are going through this circuit, so here I have first NOT gate, second NOT gate, and third NOT gate, right? So how many NOT gate I require? Three NOT gates and one AND gate, right? So total how many gates I require? I require total of 4 gates. See, only basic gates, right? So I required, if I take a NOT gate, so NOT gate IC, so NOT gate IC contains six NOT gates. In the 6 NOT gates, I am utilizing only 3. Okay, so if I utilize 3, if I have utilized 3 NOT gates, remaining 3 NOT gates are in unutilized conditions, unutilized. Okay, so there we have a space issue. Then I have to use one AND gate IC, one AND gate IC. Total how many ICs we require? I require 2 ICs, one NOT gate IC and one AND gate IC. Right? See the complexity. But here in this case, see, in the this is the designing, so I have only NAND gates, right? So total how many NAND gates I require? One NAND gate, second NAND gate, and third NAND gate. Okay, so I require 3 NAND gates. That is how many ICs I require? Only one IC I require. In the last place, in the last case I have required 2 ICs, right? But here in this case I require only one IC, right? So this is, so if I use, so space utilization is reduced, as well as so cost also reduced. Space utilization reduced, so therefore space utilization, that is complexity, also reduced. Complexity reduced, space utilization is reduced, um, as well as cost also reduced, right? This is the advantage of using the universal gate, designing the universal gate using basic gates using the universal gate, right? So this is a final circuit we have to draw using the Tinkercad. So using the Tinkercad, first we have to use 3 NAND gates, one NAND gate for giving connecting to the A bar, second NAND gate to getting the B bar, and third NAND gate to get the overall output expression, that is A plus B. This is how we have to, right? This is how we have to use connect these IC NAND gate. I require only 3 NAND gates. Okay, so let us remember first, this is my switch, right? So in this switch I required 2 inputs. This is 1A and this is 2A. So 1B and 2B is my inputs, right? So first I have to connect the IC NAND gate IC, NAND gate IC. So 7th pin is ground, 14th pin, that is VCC. So first input, second input, this is 1A, 1B. This is our output 1, output 1. 2A, 2B, this is output 2. Alright. So here I have, also, so input 1A, 1B, right? Let us see with the IC. So this is a previous circuit, not yet using the NAND gates. Right, so here I need to clear one more new circuit I am taking. So in the new circuit, first let us begin with the basic breadboard. So I am taking a breadboard. So here I am using a large breadboard. Then power supply I need, so power supply, coin cell I am providing. So this is a coin cell, Connect this positive terminal. Change the color of this positive terminal to the red. Then connecting it to negative terminal. Negative. Change the color as well with a black color. Then I have required this resistor and one LED to check the output. So LED negative terminal has to be connected to black. LED negative terminal has to connected to black. Then I required one IC, that is NAND gate IC. NAND gate IC 7400. Right. So here I am connecting somewhere here. So this is 1A, 1B, output 1, 2A, 2B, output 2. So here in the output 3, 3A, 3B. So this is 3A, 3B, output 3, output 3. This is 4A, 4B, output 4. So first short circuit, use this short circuit, right? So here output is available. Connect this first input, connect this first input to either 1A or 1B, right? So this is output available. So this output is first output. Here what is output available? That is A bar, right? Again short circuit these two or these two. So let us consider shorting these two, 4A 4B short circuit. Okay, now connect this 2B to either 4A or 4B. Okay, so now what is output available? Here I have one output available, that is B bar. This is A bar and this is B bar, right? Now what I have to give? Connect. So let us consider this is my output 1 and this is my output 4. Okay, now take one more NAND gate, that is third NAND gate, and connect output as first input and output 4. Okay, so here I am taking one more input. Okay, 2A 2B I am taking, right? So connect these output, connect this output. Okay, so connect this output to first input 2A, output connect to a output 1 to 2A, and connect this output 4 to 2B, right? So connect this output 4 to 2B, 2B. Okay, now this is my overall output which is available. Now I am connecting these to one resistor, thereby I am connecting to one LED, correct? So this is my overall output. So here I have to connect it to one LED. So this is a um, um, general view of the circuit. This is a NAND gate IC 7400, right? So three outputs I have to use. So those three outputs using this, right? So this is the same how we will going back to our circuit. So NAND gate, so NAND gate first I need to connect a switch, SPST switch. So take a switch. So for switch how many inputs are there? Two inputs. Connect 1A to VCC, change the color. Again connect 2A to VCC, right? So where is my input is available? My input is available at 1B as well as 2B. Okay, now firstly what I need to do is, first short circuiting. Okay, so first I'm using, so here I have clearly explained 1A 1B has to be short circuited and 1B has to given to this 1A or 1B, right? So first short circuit these two. So I'm short circuiting 1A and 1B. So let us change the color for input is green color. Okay, so where my input is available at 1B, my input is available. Now connect this input to either 1A or 1B. Okay, so let us consider it is a 1A, right? Now my output is available at uh, output 1. So what is my output is available at output 1? That is A bar, right? So A bar is first output, that is A bar, first output of the first NAND gate. Okay. Now again I am using the 4B and 4A. Now again short circuit 4A and 4B. So make a differencing. I'm using a different colors for different inputs. Okay, now this is a 2b. 2b is my input, second input. Whether I can connect it with a 4a or I can connect it with a 4b. So let us consider I'm connecting at the 4b, right? So meanwhile, don't forget to connecting the VCC as well as the ground. These are very important. Without these we cannot get an output. So ground black color and VCC, that is obviously it is a red color. Okay, now what is the output available at output 4? Output 4 is B bar, output 1 that is a bar. Alright, now I'm using what I'm using 2a, 2b and 2 is my next last NAND gate. Okay, now connect this output 1 to 2a. So let us change the color as a purple color. That is a first input to the third NAND gate. And where is my second input available? At output 4, my second input is available. Okay, so here from here to I'm giving as second input, that is 2p, right? So this is my A bar, that is available at 2a. At 2b, B bar is available, right? The overall output is available at output 2, right? Now where I need to connect this output to? I need to connect this output to this output 2 to resistor 1 terminal, and second terminal has to be connected to the anode and cathode has to be connected to the ground. Alright, so cathode has to be connected to the ground. So cathode already connected and one terminal is resistor terminal. Now this terminal I am connecting to resistor. So output is I am giving as a brown color. Okay, so yellow color I have indicated with to get the A bar. Green color I have indicated to get the B bar. Alright, so this purple color I have used to connect to output of, that is B bar as well as A bar. Right, and brown color I have indicated to get the overall output of the system. Right, so what is the OR gate operation? If I taking one more slide, so let us explain what is the OR gate operation. The OR gate truth table is OR gate have two inputs. So OR gate is A plus B, right? 0 0 0 1 1 0 1. So OR gate operation is at least one input is high, then definite output is high. So 0 1 1 1, right? So for 0 0 condition the output should be 0. For 0 1 it is 1. For 1 0 it is 1. For 1 1 it should be 1, right? It means if both are 0 0 0. Okay, so let us start a simulation. So here I am changing the name as, so this is how I have changed the name as OR gate using NAND gate as well as NOR gate, right? So NOR gate as well as NAND gate. Okay, so let us start a simulation. So this simulation I have started. For 0 0, what should be our output? That is 0. For 0 1, the LED should be on. It is obviously on. For 1 0, it should be on. It is on. For 1 1, it should be on condition. Hence it is proved. Now going towards the schematic view. So this is a schematic view. See. So first, how many NAND gates we have used? First NAND gate, second NAND gate, and fourth NAND gate. Okay. So this, according to whatever I have given here in the PPT, whatever I have shown, the same it will visible in terms of a schematic view. So this is a schematic view of the circuit. So resistor output, overall output, where it is available? It is available at overall output. So this is a second terminal. This is a resistor. Second terminal of the resistor has to connect it to output 2. So output 2 is the overall output. So output 1, that is a bar, and output 4, that is a B bar. A bar and B bar, it is short circuited connection, short circuited connection. Here you can see the short circuit connection. So it is a short circuit. So this is a short circuit. Okay, so here also short circuit off to get the B bar. Then A bar B bar connection given to the resistor, output resistor, then LED. Second terminal is connected to the ground terminal. Right, so this is our battery which produces the supply. Alright, so if you are going towards the component what we have used, that is a point cell resistor, LED, quad NAND gate, that is only one IC is required, SPST switch, right? So this is how we have to um, connect the, we have to convert the NAND gate as a OR gate, right? So thank you so much for learning this video. In the next class, I will explain about NAND gate using AND gate using the NAND gate, right? So that we will discuss in the next class. Thank you for learning this video. Thank you so much. Good afternoon to all. Again, welcome back to my course, Distance System Learning with Tinkercad Simulation. In the last class, we have discussed about OR using NAND gate, right? So, how to design a OR using NAND gate? So, we have considered OR using a NAND gate. So, this NAND gate, OR I have considered. So, this is a OR gate operation, and this is a NAND gate operation. So, I have considered OR gate using the uh, Boolean algebra formula. So complement of A complement double complement is equals to A. So I have applied double complement to equation number 1. Then I got Y is equals to A bar B bar whole bar. Right. So A bar I have generated using a basic gate. A bar into B bar using a AND gate. So this is also one basic gate. Again we have an OR gate. So there I have designed using, this is the overall circuit for or using a NAND gate. So this here I have used three NAND gates, and that is one IC NAND gate IC 7400. I have connected shortened these two inputs given to one NAND gate, first NAND gate, second NAND gate, third gate. Alright. So this is a circuit we have already seen in the last class. So let me check one more output, that is this is OR gate is for 0 0 it is 0, for 0 1 it should be 1, for 1 0 it should be 1, for 1 1 it should be 1, output logic will be 1, right? So this is how we have to develop OR gate using the NAND gate, right? Now next topic is based on, we have proved, we have designed the OR gate using the NAND gate. Now next one is AND using NAND gate, right? So we know, let us consider one more new slide. So here I am taking one more new slide I am considering. So we know the AND gate operation, AND gate output is Y is equals to AB, right? Y is equals to AB. So here we know this is a AND gate, and NAND gate we know the NAND not plus AND is equals to NAND, that is Y is equals to AB 1, right? So now I have to design AND gate from NAND gate, right? If I complement again it will gives us back the AND gate, right? So the same property, A complement whole complement is equals to x complement double complement is equal to x. So, so we have the same. So this is my output expression 1. So same output expression I am considering. y is equals to AB complement and one more complement. So that itself it gives as a AB. Correct. Now I required one AND gate. There I have NOT gate. Again I have NOT gate. Right. So this is how I will get a AND gate operation y is equals to AB. So after this A into B, after this NOT gate A B bar, after this NOT gate I have AB bar double. Right. So here itself you can see that you have end plus NOT. So we know end plus NOT is equals to obviously it is NAND, right? So now the same I can write it down as end plus NOT, that is replaced by one NAND gate A B. Then I have one NOT gate. So this is NAND gate. Again I have one NOT gate, right? So we know how to design NOT gate using NAND gate, right? So this is a NOT gate. So NAND gate, how we will design? We will short the two inputs of the NAND gate and given to single input, it will act as an AND gate, right? So here I require one NAND gate IC and one NOT gate IC. Again to convert back, let us consider one more new slide. So here again to convert back, so I have to use first NAND gate. This is okay, and second AB. The output is AB bar. Now I have again one NOT gate. So how to convert a NOT gate? Connect NOT gate using NAND again by short circuiting two inputs of the NAND gate to a single input. So here it will give A B bar double bar. That is AB. That is our AND gate. Right. So here 7400 IC. How many it is required? Only one. But in this case, if you observe, so I require one AND gate and two NOT gates. It means one AND gate IC and two NOT gate ICs I require. Two NOT gate ICs I require. Right? So instead of using two separate ICs, so it makes a complex of the system. Then I have connected everyone overall with the only NAND gates. So this is how this is how the advantage of the universal gates. Right? Now 7400. So here I have a, so this is a NAND gate IC 2, 3, 1A, 1B, output 1. So here 2A, 2B, output 2. So here it is ground. Again I have VCC 14th pin. Then I have, so here 4A, 4B, output 4. 3A, 3B, output 3. Alright. So how many inputs I require? I require switch. So two switches I am considering. This is 1A and this is 2A. 1B, 2B. Correct. So what I need to do? I have to use two NAND gates. One NAND gate here and second NAND gate here. Okay. So first connect one input. First input to. So this is my first input. I am connecting to 1A. And this is my second input. I am connecting it to 1B. Right? So this is the first NAND gate. So what is the output available at output 3? At output 3, the output is available is AB whole complement. Now again I have to use, so what I have to do, I have to short circuit. Okay, so here I have used first NAND gate, second NAND gate I am considering is like this. So first short circuit these two, so 2A and 2B is short circuited like here. Okay, so what I need to do is I have to connect the output to any one pin, either 2A or 2B. The output has to be connected to either 2A or 2B, right? So this is my overall output. So what is my overall output available? That is AB complement double complement. That is AB. Right? Now here I have one resistor I have to connect it to, and second terminal of the resistor I have to connect it to this LED. So this is LED. Then cathode has to be connected to ground, right? So this is 7400 NAND gate IC, right? So here I have internal circuit as this is one NAND gate, output is connected here. This is second NAND gate, output is connected here. Okay. Now here also 3A 3B connected and this is output. So here also this is output. Alright. So this is same. We will going towards this Tinkercad simulation. So same. So let us change the circuit. So here and using NAND gate and using NAND gate. Alright. So the basic operations. So whatever we have. So those I'm deleting here. So let us take a new circuit. New circuit. Breadboard. Breadboard. Then power supply. Then resistor. Then LED switch. Connect the switch. Then we require NAND gate IC. NAND gate IC. Alright. So all the connections, I think all the connections we have done with. First connect this to positive. Then connect the negative terminal of the cell. Then we have negative terminal connected to ground. Then here also we have a ground operation, ground pin. For IC, this is a VCC. Now connect 1A, 2A to the VCC and 1B, 2B are the inputs, right? So what we have to do, first connect 1A, 1B to first NAND gate. Their output has to be short circuited and connected to second NAND gate, right? Now first connect 1A. So here I am using here. Let us change the color as yellow. Again connect second input to 1B. Second input to 1B, right? So what is output available here? Here NAND gate output, that is AB bar, AB whole bar. Now what I have done here, I have short circuited 2A 2B and connected the output 1 to either 2A or 2B, right? So I have short circuited, first short circuit these two short circuited green color and connect the output of these two, either this pin or this pin, right? So let us consider this is uh, in output of AB whole bar connected to pin number input to A, right? So this is my overall output that is available at the output 2. Now for output 2, let us use a one more color. So here I have an output. So here I have an output. So this output I have to connect it to one terminal of the resistor. Second terminal has to connect it to anode, and LED cathode is connected to the ground terminal. Right. So this is how we can connect the AND gate using the NAND gate. Then what is my output here? Inputs are A, B, output is Y. Output is Y. Output is Y. For 0 as well as 0, what is my output? AND gate output is 0. For 0 and 1, what is the AND gate output? 0. For 1, 0, what is the AND gate output? Again it is 0. For 1, 1, AND gate output is 1. So AND gate is, if both the inputs are 1, then only the output is 1, otherwise the output is 0. Right? Now we have to check with the simulation. So change this and using NAND and NOR also will explain. So start the simulation. If you are starting the simulation for 0, 0, the output is 0. For 0, 1, again the output is 0. You can observe LED on and off. For 1, 0, 1, 0, the LED is 0. And the last condition for 1, 1, the LED is glowing, that is on condition. So this is how you can develop your AND gate using the NAND gate circuit. Right? Right? So same way we can develop the remaining circuits also. Now again going back to the AND gate using the NOR gate. Right? So we know the AND using the NOR. Okay. So let us consider one more slide. So here, what is the AND gate output expression? The AND gate output expression is Y is equals to AB. Right? So what is the output expression for NOR gate? The output expression for NOR gate is Y is equal to A plus B complement. Right? Now apply double complement on both sides. Double complement using the same formula. So if you are applying the double complement, Y complement double complement is equals to Y, that is equals to AB complement double complement. So first apply the first complement on the internal part, then A becomes A bar, dot becomes plus, B becomes B bar double complement. See, this is output expression for NOR gate. So here I have an output expression, that is Y is equal to A bar plus B bar double bar. That is same output expression, but instead of I have a bar and B bar. Right? So let us develop this using the basic circuits. So first I have to generate A bar. So I required A bar. Again I have to generate B bar. So for that I required one NOT gate, that is B bar. How A bar and B bar is connected? A bar and B bar are connected through OR gate. So this is OR gate. Right? After that I have again one more NOT gate. Okay. So totally how many NOT gates are required? 1, 2, 3. That is 3 NOT gates I required and 1 OR gate. Total ICs, number of ICs required, total ICs are 2. Right? Now if I develop this circuit using only NOR gate, okay, so we know already how to design this NOT gate using the NOR gate in the same way of NAND gate. So we will short circuit the two inputs of the NOR gate and connect it to single input, then it will generate the NOT gate. Okay, so remember the basic points. So this is a basic structure we have. So same way in here we have to generate A bar, here we have to generate B bar, then we have to generate OR So here you can observe that. So we have OR plus NOT. OR gate plus NOT gate. What is OR plus NOT? That is equals to NOT gate. Right? So we require one. So this is a circuit. First and NOT gate. Second NOT gate connected with NOR gate. OR plus NOT is NOR gate. Right? So this is A, this is B. Here I bar, here B bar expression will get. So A bar plus B bar complement, that is equals to AB. If you apply again complement, then you will get A complement double complement plus becomes dot B complement double complement, that is equals to AB. So this is a AND gate, right? So this is what how we have to develop the AND gate using the NOR gates. Now replace basic gate with the NOR gates, right? Again if I replace, so short circuit and connected to one NOR gate. This is again short circuit and connected to one more NOR. A, B. Now connect these to one NOR. So here how many NOR gates are required? 1, 2, 3. So here it will generate A bar, B bar. Here it will generate A B. That is our AND gate output expression. Right? Now, right? The same we will consider the NOR gate IC. NOR gate ICs we will consider. So NOR gate IC we have to consider NOR gate IC. So I have already told you NOR gate IC is little different than all the ICs. So first output is available, output 1. Then we have inputs. Again output 2, we have 2 more inputs. Right? So this is ground pin. NOR gate IC. Let us go with the same thing and that simulation. Stop simulation before doing anything. So let us move on to the circuit. Again breadboard. Again breadboard. Cell. Resistor. LED. LED to change the color, it has green color. Then we have SPST switch IC, NOR gate IC, NOR IC. So IC is 7402. So 7402. See, first output 1, input A, input B. So output 2, 2A, 2B. So this is output 2, 2A, 2B. Right? So this is 1A, 1B. Output 2, 2A, 2B. Similarly, on the other side, we have 3A, 3B, output 3. 3A, 3B, output 3. This is 3A, 3B. This is output 3. Again, 4A, 4B, output 4. Right? So what we have to do is, we have to connect. First we have to get A bar, B bar. Then we have to use third NOR gate. Right? In the same way, first this is a switch. 2 switches we require. This is 1A, this is 2A, 1B, 2B. Connect 1A, 2A to VCC. Now 1B, 2B is my input. Okay. So what I have to do? I have to first short circuit. First short circuit gives 2 and connect it to first input to get the A bar. Right. So what is the output available here? Here the output available is A bar. Then again, short circuit 2A and 2B and connect the switch output to either 2A or 2B. So here I am connecting at the 2B, right? So what is the output available here? That is output available is B bar, right? Now I will use this, whether you can use this combination or this combination, that is your wish, right? Now connect this A bar. So connect this A bar to connect this A bar to 4B and connect this B bar to 4A, right? Now where is my overall output is available? My overall output is available at the output 4. Now connect from here to one resistor and one LED, then connected to ground, right? So there you have to see whether it will produces 0 0 0 1 1 0 1 1 combination. So end gate is AB. So whether it will produces the indicate logic function or not. For 0 0 it is 0, 0 1 0, 1 0 0, 1 1 it should be 1. So this is a indicate truth table. So that it has to be satisfied after connection, right? Now we have first positive, connect this positive, then connect the negative point, black color, then connect this cathode to ground, then connect this 7th pin to ground, 14th pin to VCC, change the color as red color. Now this connect 1A to VCC, again 2A to VCC, right? So 1B, 2B are the inputs. So what we have to do, I have to first short circuit these two. So short circuit to get A bar. So A bar has to be get and B bar has to be get, right? So connect this 1A, 1B to any one input pin, either at 1A or 1B. So here I am using to 1A, right? Similarly, so there this is output available. This output is available is A bar. Now again short circuit. So here I am considering this and this. Short circuit again these two and connect the input B, 2B to maybe at 4A or 4B, right? So this is output available which is V1. Now connects. So your wish whether you can use a combination 1 2 3 or you can use a combination that is 13 12 and 11, right? Now here my own output is available, that is B bar. Here one output is available at pin number 1, that is the A bar. Now connect, this is one output, connect these two. Here I am considering again 3A 3B, or let us consider it is at here, right? So change the color to get the final output. So it is, I am giving it as a yellow. Now where is my second output is available? My second output is available here. Connect it to 2B, right? So my overall output is available at output number 2. Now connect this output number 2 to one terminal of the resistor, that is my final output of the circuit. Right? So I think I am clear about all the connections. First generate A bar, then generate B bar, and use one more NOR gate to connect A bar to connect B bar and get your final logic, that is AV, AND gate logic. Right? Now let us start the simulation. So same simulation. For 0 0 the output should be 0. For 0 1 output is off. For 1 0 third condition the output is off. And last condition for 1 1 the LED is glowing. That is our AND gate operation. So this is how you have to connect using this Tinkercad circuit. Right? I hope I have given a clear idea about this AND gate using the NAND gate as well as the NOR gate, right? So these are the outputs. This is for output. For 1 1 operation, it is the output is 1 1. The output is 1 1. For 0 0, if you are considering NAND gate for 0 1, again for 1 0, again for 1 1. So here also LED is glowing for 1 1 operation. Here also LED is glowing for 1 1 condition. Right? So this is how we have to develop our system. So thank you so much for understanding this video. So in the next class, we'll discuss about how to convert OR gate, that is you how to connect OR gate using the NOR gate operation. So let us go with the NOR gate operation. NOR gate. OR using NOR, right? So this is the last conversion basic gate to converting to converting using a universal gates, right? So this is a OR gate. So we know OR gate is, so to get the OR gate using the NOR gate, it is very easy, right? So let us consider this is the output for OR gate expression. This is OR gate expression. This is an OR gate expression, right? NOR gate is a plus b whole bar, a plus b bar, right? So using the same theorem, so if I use a plus b complement double complement, so first apply the complement of the signal, then I will get NOR gate. So this itself is call it as a one NOR gate with a NOR plus NOR gives a OR gate a plus b. Alright. So first connect a b. Let us consider first connect a plus b. This is a plus b. A plus b. Connect to NOT gates. Again it will give. So here it is a plus b. Here the output is a plus b complement. Here the output is a plus b complement double complement, that is equals to a plus b. A plus b. Here if you observe here, so here we have R plus NOT. So we know R plus NOT is NOR gate, right? So here we have one NOR gate and again one NOT gate. We know how to convert NOT by NOT, right? NOT by NOT. After that, so we have A, B, one NOR gate. Again, by short circuiting two inputs of the NOR gate and connecting to single input, there will get a NOR gate, right? So output at this point is A plus B complement. So here the output is A plus B complement double complement, that is equals to A plus B. That is our OR gate. OR gate output expression, right? So what we have to do? We have to consider this is a switch 1A, 2A, 1B, 2B, right? Now we have IC. Now we have IC. So this IC is first output 1, 1A, 1B, output 2, 2A, 2B. This is ground. Potent pin is VCC. Now we have output 4, 4B, 4A. We have this is output 4, 4B, 4A. This is output 3, 3B, 3. Right? Now connect this and these two VCC, VCC. Now 2A is 2B, right? So what we have to do? We have require only two NOR gates, right? Only two NOR gates we can use. So first connect this 1A to 1A, 2B to 2B of the IC, right? So here one output is available. That output is A plus B complement. Now what I need to do? I have to make a short circuit. That is, here I am using a pin number 5 and pin number 6. So short circuit these two. So where my output is available? Here my output is available. Connect this output to any one input terminal. Correct? So here my overall output is available. Connected to resistor and connect it to the LED. Then from the to the ground. From that to the ground. Correct? So overall output is available at output number 2. The same circuit we are designing using the Tinkercad. So let us go with the tinkering circuit. Now earlierly I have used so here anywhere anytime you can want you can access all your circuit. So this is a circuit I have connected with I have designed with or using NAND gate. Now I'm designing using a NOR gate. Right? The same circuit I'm considering. So let us drag this circuit. Right? So consider breadboard. I'm considering the breadboard. So here from here to here you can use a supply, right? So from this circuit I am using a power supply to this circuit. So this is ground, and from here to or from I'm using the power supply from here to here. Right? So change this color. Change the color. That is a red color I'm using. Change this color, the red color. Right? Now again I need switch. So from here I can take the inputs, or from here again I can take the switch, SPST switch. So let us drag it. Connect this 1A to VCC. Again connect this 1B to VCC. Right? Now we have 1B and 2B. 1B and 2B. Right? So again I have to take NOR gate IC 37 port 02. So let us take NOR gate IC. Then I have resistor, connect resistor. I have LED, connect this LED, connect this LED, alright. Connect this LED. So what I did here, first to connect AB to one NOR gate. So first connect this 1B and 2B to first 1B connected, second 2B is connected to second input, second input. So here my output is available is A plus B whole bar. Okay. So A plus B whole bar. Then what I have to do with the next process, next short circuit 2A 2B and connect any one output of this to any one input, that is 2A or 2B, that is 2A or 2B. Then I have output here, short circuit 2A and 2B. Now connect this 14th pin to VCC, connect this 14th pin to VCC and this pin to ground terminal. Ground terminal. Let us change it is a black color. So here I'm changing two inputs of the color with a yellow color. So this is also yellow color I'm changing. Right? Now short circuit these two, changing with a dark. Then I have an output. This output, this output I have to connect it to any one input terminal. So here I am connecting with a 2A. Okay. So where is my overall output is available? My overall output is available at pin number 4. So this I have to connect it to one terminal of the resistor. One terminal of the resistor. Correct? So this is how I have to connect. Then this connect this to the ground terminal. Cathode to ground terminal. Right? So this is overall circuit of the node. Now start the simulation. So for 0 0 the output should be 0. For 0 1 OR gate output is on. Right? For 1 0 that is on. For 1 1 condition also the LED is on. So this is how you have to make a connection with the convert the NOR gate as a OR gate, right? So this is the overall conversions. So in this class we have discussed about how to convert AND using NAND gate, AND using NOR gate, as well as how to convert OR using a NOR gate and so on, right? So coming back to summary of overall summary, NAND and NOR gates are very powerful tools in the digital logic. So any basic gates, that is AND gate, OR gate and AND gate, NOT gate, can be implemented NAND or NOR. So this makes circuit design simpler and more efficient, flexible, as well as cost also reduces if we are using these universal gates in the designing of the circuit. Thank you so much. Thank you for watching this video, as well as thank you for learning this course.